We will solve the gas station circuit problem. The input is two circular arrays, gas and cost. We must return all starting indices, where a car with zero initial fuel can complete a full loop. The goal is linear time, big O of n, and no extra space beyond linear. Imagine stations placed around a circular track. At station I you gain gas of I, and driving to the next station costs cost of I. You start with zero fuel, and the tank cannot go below zero at any time. Here is a first example. We will use 5 stations. This one has a unique valid start. We define diff of I equals gas of I minus cost of I. This captures the net change in your fuel on each hop. A starting index S is valid if the running sum from S never drops below zero while moving n steps. In math, let d of I be diff of I, and let cumulative of t be the sum from k equals S to t of d of k along the circle. We require cumulative of t is at least 0 for all t from S to S plus n minus 1. We now convert this circular condition into a straight line condition with prefix sums. We double the diff array and compute prefix sums. A start S is valid if the minimum prefix in the window from S plus 1 to S plus n is at least the prefix at S. To check all starts in linear time, we slide a window of length n over the prefix array and maintain a deque of indices with non-decreasing prefix values. The front of the deque stores the index of the minimum prefix in the current window. Start S is valid if prefix at deque front is at least prefix of S. As we slide by one, we discard indices that leave the window and push the new index, popping from the right while larger. At start 1, we check the minimum, and then again at start 3, which is valid here. Algorithm summary. 1. Form diff equals gas minus cost. 2. Compute prefix on double diff. 3. Slide a window of length n on prefix. 4. Maintain a non-decreasing deque of prefix indices. 5. For each start S, valid if prefix at deque front is at least prefix at S. This runs in time big O of n and uses linear space for the doubled prefix. For example 1, the only valid start is index 3. We mark it in green. Here is a second example with 4 stations, where every start is valid. Compute diff, for example 2. All entries are positive, so any start will maintain non-negative fuel. Therefore, all starting indices are valid in this case. Graphical intuition. Think of diff as vertical steps up or down. Starting at S is valid if the cumulative path from S never dips below the start height during the next n steps. The minimum over that window controls feasibility, which is why the sliding minimum solves the problem in linear time. Checklist for any instance. 1. Compute diff. 2. Build prefix on the doubled array. 3. Slide a length n window and maintain the minimum with a monotone deque. Report all starts where the window minimum is at least the start prefix. Time complexity is linear in n, memory is linear for the doubled prefix.